Okay, we're talking about area and distances. So it kind of sounds like two completely separate things. But what we're actually finding here is we're trying to find what the area underneath this curve is. Okay, so right now it's linear. It's not always going to be linear. Sometimes you'll have, a nice curvy graph and you're trying to find what the area underneath that curve is. So this guy, his name was Riemann. I just think whenever I hear Riemann, I think rectangles because he just said, okay, we're going to break it into a certain number of rectangles, find the area of those rectangles, and that'll give us an okay estimate of it. Okay, so if we just broke this into like the very first one, top left, if we broke it into 4 rectangles, is this an over or an underestimate? Underestimate, right? Because we've got all that extra space there that's underneath. Does that make sense? Okay. But if we move over here and we do the rectangles the way they did on the top right, isn't that an overestimate because you got that extra stuff? Okay. And if we average those, we could get an okay idea, but that's not even what we're going to do. We're just going to say, okay, it's close to this, but we know it's going to be more than that because this is an underestimate. Okay. So if I do 4 rectangles, it's an okay estimate. What would happen if I did 8 rectangles? If I did 8 rectangles, so instead of going from here to here, I go here to here. So do you see how they went on the very left-hand side, went up to the graph, and then drew a rectangle? We're going to do that, but we're going to do it 8 times. So now this is the left-hand side. We're going to go up to the graph, draw a rectangle. Then this is the left-hand side. We go up, we draw a rectangle. Then this is the left-hand side, go up, draw a rectangle. So is this going to be more accurate or less accurate? More. Okay, what would happen if I made this into 100 rectangles? It's going to be way more accurate, right? So the more rectangles you get, the more accurate it gets. And that's actually what the integral does. Is we just talked about the integral as, okay, you just take the antiderivative, right? What the integral means for the graph is when you take the integral, you end up finding what that area is under the curve. So let's say I go from 0 to 2. Let's say this here goes from 0 to 2. You're finding what the exact area is under that curve. So what the integral says, if you read through all of the work done about it, is we're breaking it into an infinite number of rectangles, so we get the exact area. Okay, so that's the idea, is when you do the integral, you find the area, finds exact area under a curve. But for right now, all we're going to do is get estimates. Okay, and we'll work our way into doing those, which those you already kind of have a good idea of how to do, so that's not difficult by any means. Sometimes you can't do an integral because we can't find the antiderivative. So if you can't find the antiderivative, then you can't actually evaluate the integral unless you have your calculator. Sometimes if we flip a couple of pages forward, you're given a table of values. So can you put a function in the integral if you're given a table? You could estimate a function, couldn't you, to that table, but that doesn't mean that it's accurate. So then with something like that, you would have to estimate, and when you see that word estimate, that means you're going to use Riemann sums to estimate what that distance traveled is. And it's weird because we're talking about area on page 1, and here we're talking about distance traveled. But if you think about this for a second, we won't actually do this problem today. What is my x-axis in? So what's the label for my x-axis down here based off that table? Time, right? So this is my time, which is in seconds. And then my y-axis is in velocity, which is meters per second. Okay, if I draw a rectangle, because I'm, estimating, and actually I shouldn't draw a curve for this one. So let's say I've got, these data points, I'm points over there. So let's say I've got those data points, and so I decide I'm going to draw rectangles here to estimate that. So the rectangles would look something like this. So I just did 4 rectangles. If I found the area of one of those rectangles, isn't the area taking the base times the height? And our base is in seconds, and our height is in what? meters per second. What happens when you take seconds times meters per second? You just get meters, right? So that's why it's estimating the distance. So when you're actually finding what the area is under a curve and you have labels that, are like this, which is what it is most of the time, you end up with what that distance traveled is. So always check that those labels match up. I'm sure there's probably a homework problem where they don't. And on occasion on the AP test, they'll do that. Typically, it's not something they're going to do more than once probably on the AP test, but it's something that obviously those need to match up. Otherwise, it doesn't make any sense, Okay? So are you kind of understanding what the rectangles are doing? Okay, so Riemann sums, we're doing rectangles. When it says left Riemann sum here, that just means you go at the left endpoint. So if we're going from here to here, the left endpoint would be this one, right? Then we go from here to here, and the left endpoint's this one. And then we go from here to here, and the left endpoint is this one. And then the last one, we go from here to here, and the left endpoint's this one. Do I even use what this data point is over here? No, not for left endpoints. Okay, now if you move over to on this side here, we're still doing left endpoints. The curve is just different. So do you see how they went on the left endpoint, went up to the graph and drew the rectangle? And then from here to here, they took the left endpoint, went up to the graph, drew their rectangle. Okay, here to here, they went left endpoint, went up to the graph, drew the rectangle. And then here to here, same thing. Okay, went up to the graph, drew the rectangle. So you don't even use that last endpoint. And if you look at the bottom, what's the difference between the top and the bottom? We're talking about right endpoints here. So do you see the difference? So which point is not used for this? The first one, right? Because when you're going from here to here, you go for the right endpoint, and then you're just going to ignore that first value. So if you're talking about a table of values, it's important to realize that you're not using every single data value. You'll be skipping one or the other, okay? Now, we talked about left Riemann sums and right Riemann sums. So this is our left Riemann sum. The little 4 means we're doing 4 rectangles. Okay, this is right Riemann sums. We got 4 rectangles. Any idea what M might stand for? We haven't talked about it yet. Midpoint. Okay, so what that means is if we're going, let's just use the graph we haven't drawn on yet. If we're going from here to here, point of that, right in between, right? So you would go up to the graph right in between, and you would plot a point and draw a rectangle on that interval that hits at the midpoint. Does that make sense? So do you see how this gives you a little bit of an under and a little bit of an over? So midpoints are a lot more accurate most of the time. I'm not going to say all of the time because it depends what's happening with the graph. But for something like this, it for sure would be. So then you go from here to here. You go at that midpoint. You plot the point on the graph, and then you draw the rectangle over that interval. So you see how all of those with a linear graph like this would end up being a little over and a little under. And with something that's linear, it would end up actually evening out. But with something like this, it's not linear. The midpoints will be a little bit off. I'm going to take I off right now. So go ahead and list these in order from smallest to largest. Okay, so you're doing 4 rectangles for all of them. And then compare what would happen if you did left, right, and midpoint. You don't actually have to calculate it. Just think about it. One's an overestimate, one's an underestimate. That kind of helps you get them in order. And the I back here that I took off is the actual, what the actual area under the curve is. It's just hard to compare the midpoint with the actual sometimes. And it's not something they do on the AP test, so we're just going to kind of ignore it for now. Anyone feel like they know which one's the smallest out of those? The left? Okay, so let's take a look at the left here first. So with left endpoints, we're doing 4. So you want to split this into 4 chunks. So if I'm going from here to here, I'm going to split it here, and then split it, I think there's a line there, it's just hard to see, and then here. Okay, so that's 4 chunks, right? Then you go to the left-hand side of each of those pieces. So from here to here, we're going on the left-hand side. What's that rectangle going to look like? Non-existent, right? It's right on the axis. So there's like no area there. And then from here to here, we go on the left-hand side, find where that hits the graph, draw a rectangle. Do the same thing with the next one. Okay, so here's the left-hand side. Go up to the graph and draw your rectangle. This doesn't look exact maybe, but you get lines, I think, on your paper. And then same thing for the last one. So left-hand side, we go up to the graph, find where it hits, go across. So that's definitely over or under. An underestimate, right? We're missing all of those little pieces there. So that one looks good to be our smallest one. So I'm just going to go like this, but you could, it says in order from smallest to largest, so you could say L4, comma. So which one would go next? Midpoint, good. Okay, so with midpoint, you're using those same intervals, but you're going at the middle spots of those. And you're going up to the graph, plotting where those points are. That's about right. And then you're drawing in those rectangles. So this rectangle is a little bit under and a little bit over. Same thing with the next one. And so we've got those. So this one is definitely more area than the yellow one. You can tell that. And then the largest one would have to be the right. So looking at the right endpoints, they're actually the same as those left endpoints. We're just going the opposite direction with those. And then the last one we would need to find would be way up here somewhere. So that's definitely the largest there. So any questions on comparing those three? Do you see how the actual might be kind of hard to determine if it's bigger or smaller than the midpoint? And to determine that, I would have to like really make this crazy concave up and then try to figure it out. Like if we're looking at the pink graphs, does it look like there's more under or more over? So I would probably look at like this one here. Does it look like we have more that's over or more that's under? It looks like there's more that's under. So the actual area would actually be bigger. So I would put it going like this, the M4, and then, whoops, and then I, and then R4. But I didn't require you to put that in there because that one's kind of a tricky one, and you won't see that on the AP test. I don't think I've seen one problem with that. So, questions? Concept makes sense? Okay, now there it didn't say you had to draw all that, so you didn't have to. Here you're going to have to draw some of that, so that's where I wanted to get you kind of thinking about this. So this is page 293. I think the graph is on your paper, but I'm not sure that the points are. So I just put like what the main points were here, so you could sketch in what that looks like on your, or in your book there. So if you plot those points, that'll get you the graph. Let me glance at yours here. So for one, it says by reading values from the given graph, use 4 rectangles. So we're trying to use 4 rectangles here to find a lower estimate and an upper estimate for the area under the given graph from 0 to 8. So we're going from 0 to 8. Just be very careful you read the directions because it's easy to lose points for that. Okay, so 0 to 8, we're going here. And how many rectangles do we want? 4. So what's our width of those rectangles going to be? 2. Okay, so we're going to go 0 to 2 to 4, 6, and to 8. And then think about what gives you a lower estimate and an upper estimate, and we'll find those. And then, okay, so what's going to give us a lower estimate? Let's start with that. Left. Okay, so, and that's not always the case, okay? Just because this one's increasing Our lower estimate will come from left. So let's do the left with 4 rectangles up here. What's going to give us an upper estimate? The right will. Now, if you read part B, it says find new estimates using 8 rectangles in each case. So let's not do 4 problems here. Let's just do 2. Okay? So we'll do left endpoint with 4 rectangles. So this is kind of like part A, only part A actually requires you to do both. And then we're going to do upper with 8 rectangles. Okay, and actually sketch it on there. So I'll give you guys a few minutes. I'll come check your work and we'll see if we need to clarify anything, because it's easy to misunderstand something and we don't want that going on. Okay, so you're actually trying to find what the area of those rectangles is. So I'll let you think about that on your own without just telling you. Do you feel like we might have that top one? We might have both of them. Okay, but we're trying to find the area of all of those rectangles. So first I'm just going to try to sketch them. So we're doing left and 4. So you're going from here to here. Now with a graph, your answers might not match exactly, and my sketch might not be exactly like the book if you're using that. But if I'm using a left hand, it's going to go like this, right? So the area of that rectangle, the base is 2 and the height is 2. So 2 times 2, I'm just going to write it out. Okay, the next rectangle from here to here, you go up and then over. So the base is again 2. And the height there, this is where it might vary a little. Mine looks like it's like 3.7 or something like that. Does the book look more like 4? I'm not sure. It might. Yeah, so then you can just put 4 there. So let's just switch that if that's what you guys had. Okay, now the next one, I already wrote the 2 because I know my width is always 2 here. So that one's going to have a width of 2 and a height of 5. Make sure I have it counted for right. And then the last one is again 2 and maybe 5 point, what'd you put, 5.5 or 5.6 or something? What'd you put? 5.5, let's just go with that. And then you just add these up, so we've got 4 plus 8 plus 10 plus 11. 33, is that what you guys got? So questions on that? Does it ask that? Yep, so if it asks that, this is definitely an underestimate because we're missing like all of this stuff here, because that's what the actual area would be. So yeah, if it's asking if it's an over and under, this one is an underestimate. And do you see how if I did write endpoints on this, I would end up with an overestimate? Okay, so then those two, it's got your actual area, you know, is between those two values. Averaging them, I mean, it'd be more accurate, but it doesn't give you the exact value anyway, so they're never going to have you do that type of a thing. Okay, so upper with 8 rectangles will be similar here, but what's our width going to be for all of these? 1, right? Or our base, if you're talking base and height or length and width, but our base is always going to be 1, where here our base was 2. So up here, if you know your base is consistent, you could have just pulled the 2 out and then found all of those heights. So it'd just be 2 plus 4 plus 5 plus 5.5. So you could have work shown like that too. It would be the same thing. Okay, so down here we know our width is 1 for all of those, so I'm just going to put the 1 out front. And we're talking about right-hand side, so from here to here, you're going on the right-hand side, going up to the graph and going over. So that's what our first rectangle would look like. Our second one would go on this side. Our third one would go here, and so on. What do you guys get for a value for this? Like 38 something. I got like 39.2 on my paper, so something right around there. So if you're doing an estimate and your answer doesn't match an answer key exactly, that's okay. You know, check to make sure that your values are comparable, because maybe you accidentally did left and you were supposed to do right or something like that. Just be careful of that. But does everyone see how to finish that? So how many things would be in the parentheses back here? 8 of them, right? So we're good. So about 39-ish. So is this over or under? Over, right? I've got all this little extra stuff up here, so it makes it an overestimate. So that's something else that you could write. I definitely would say this concept is not like, whoa, earth-shattering or anything like that, but you're going to see it on the AP test. And it surprises me, like when we do practice AP questions, how many people mess something up with it, and it's like so simple compared to some of the stuff, but it's so easy to mess something up because you've got all these little things going on. Or like you get back to a problem like this, and this one's not terrible, because if you look at the time, do you see how it's going up by the same amount each time? When it's not going up by the same amount each time, I think that's where people start to go, oh, I can't do this because the width is different. You still just break it into rectangles and find the area of each rectangle, and it's super easy to get those points. You just have to like really understand the concept. So I would say for homework, just do 2, 4, and 6. Okay, it seems like super quick, but if you look at 2, 4, and 6, don't they have a bunch of parts where you're like sketching it? So use 6 rectangles to find estimates for each type from 0 to 12. So you're doing left hand with 6, right hand with 6, midpoint with 6. So it'll take a little bit of time. I'll get some graph paper. Yep. And I'll get you your test here so you can do a little bit of corrections there too.